Hello, I am Mr. Murphy, and today in this video we're going to be looking at power standard number 14. In this power standard we're going to be looking at one of your probably favorite things to do, and that is story problems. Okay, or maybe it's not your favorite, but in these story problems it's not going to be too difficult. We're going to be looking at the height of an object story problems, so story problems involving the height of an object after a certain amount of time. And actually with these problems we're going to be able to use our TI Inspire calculators. So you'll want to have that out and follow along with how to do these individual steps. Don't just watch the video on how to do these steps. You're going to want to follow along and actually do it on your calculator so you can make sure that you know how to actually do it for yourself. So to start out with, let's look at the particular equation that we're going to be using. Again, we call this the height of an object formula. It's h equals the opposite of 1/2 g times t squared plus v sub 0 times t plus h sub 0. Now, what do these different pieces represent? Well, the g represents the gravity, which could be one of two numbers. It could be 32 feet per second squared or 9.8 meters per second squared. Now, the key there is to make sure that you read your story problem if the equation's not given to you, and figure out whether the numbers they're giving us is in feet or in meters. If all the numbers that they give us is in feet, we know that we would use 32 as your value for g. If our numbers are given to us in meters, we would use 9.8. Or sometimes if the problems that we're going to look at today, for example, if they give you the actual equation, we can figure out whether our numbers are supposed to be in units dealing with feet or in meters. Because half of 32 would be 16. So if your equation starts out as negative 16 times t squared, we would know that our units are all going to be measured in feet. If our equation starts out giving us the number negative 4.9, well, half of 9.8 is 4.9. So if they give us negative 4.9, we know that our units would be measured in meters. Now, what does that h sub 0 and v sub 0 represent? Well, the v sub 0 represents your initial velocity, so how fast the object is going at the beginning. H sub 0 represents the initial height, or what's the height that the object is being thrown from or kicked from or launched from at the very beginning. Well, let's look at an actual example here so you can see how we would use our calculator to find some different pieces. I know that looks like a lot, but again, we're going to be using our calculator to figure out how to find all these individual pieces, so don't freak out about things yet. It's going to be pretty easy. Well, let's look at this first equation. The equation is negative 16 times t squared plus 40t plus 8. Well, they ask us to find out what's the y-intercept and what does it represent, what's the positive x-intercept and what does it represent, and what's the vertex and what does it represent. Well, let's start by getting out your calculators. Okay, so here's our calculator. So what we're going to want to do at this point is, first off, talk about the fact that our equation, even though they give us an equation as negative 16 times t squared, your calculator has no idea what t is when we go to graph it. It only knows what x is. So when we go to a graphing screen, and we go to type in our equation, you want to make sure that you are not using t. You want to make sure that you're using x. Okay, so what we're going to start out by doing again is typing in this equation. So we negative 16 x squared plus 40, plus 40x plus 8. Okay, so now let's go ahead and graph that by hitting enter. And if you notice, we don't see the whole graph, and that's okay. Now, the first part of this question asks us to figure out, well, what is the y-intercept and what does it represent? Well, the y-intercept, we didn't even need the graph to be able to find out what the y-intercept is, because remember, the y-intercept is where x is 0. Well, in this case, where t is 0. The y-intercept would be, if I put 0 in here for t, my y-intercept would be the point where x is 0, y is 8. And this represents the initial height, or where the ball is being thrown from. So the y-intercept represents the initial height. So the ball is being thrown from a height of 8 feet. Then it says, what is the positive x-intercept? Well, this is where we're going to use our graph. And our x-intercept we can see is in here. Well, we want to figure out, we don't want to guess what that number is. I can see here that since my units are counting by 1, I can see it's somewhere between 2 and 3 units. But to find the exact value, here's what you're going to do. You go to Menu, and we're going to analyze this graph. Now, we haven't talked about this yet. We're going to be actually talking about this in the next power standard, but your x-intercept is the same as it's 0. So we're going to find the 0 for this graph. And if you notice now I have this finger with this dashed line, and over here in the left corner here it says lower bound. Well, what I'm going to do is I'm going to move my, since I'm trying to find the x-intercept, I'm going to have my finger be, for the lower bound, be to the left of where my x-intercept would be. And I'm just going to hit enter. Now notice if you see in the bottom left-hand corner there, it says upper bound. Well, if I drag my finger to the right there, you can see actually it gives me 0, and it gives me this point, real faint. But now if I hit enter again, it shows me that my x-intercept is 2.70. And what that represents is that's when the ball hits the ground. And the x value, remember, in this case is your value for t in our equation, which represents your time. So this represents the fact that the ball hit the ground after 2.7 seconds, or whatever the object is. So that's what our positive x-intercept represents. Now they ask us to figure out, well, what is the vertex and what does it represent? To find your vertex, if you notice your vertex is way up here, it's off our grid, but that's okay. We're going to find our vertex in a similar way to what we just did to find the x-intercept. If we go back to the menu, and we're going to again analyze this graph. Now when a parabola is opening downward like we have here, the vertex represents the maximum value. And just like before, now I know my vertex is somewhere up here, so I'm going to have my cursor, or my finger here, to be somewhere to the left of it. And if you have no idea where it is, you can be generous and go way left. And I'm going to hit enter, because remember that represents my lower bound, and now the bottom left corner, just like before, change to my upper bound. And I'm going to slide my finger over here, so I know somewhere in this gray shaded region is where my vertex is going to be. So if I hit enter, it actually zooms out for us so we can see what our vertex would be. Our vertex here is the coordinate 1.3 and 33. And if you think about the path the ball would travel when you throw it up in the air, it's going to follow in the shape of a parabola. And in this particular example, the x part of that vertex represents your time, and the y value represents the height. So this means that after 1.3 seconds, the ball reached its maximum height of 33 feet. So that's what the vertex represents. Now I want you to give this a shot on your own. I want you to work this next problem out. Using this equation, h equals negative 4.9 times t squared plus 15t plus 2. I want you to use or figure out what the y-intercept would be. And again, you don't need to look at the graph for that. You can look at the equation to find the y-intercept and interpret what it means. And then I want you to find the positive x-intercept and figure out what it represents, and find the vertex and determine what it represents. So go ahead and pause the video to take a minute to find those things, and then hit play when you're ready to check your answer. Okay, let's see how you did with this. So if you graph this, by the way, if you got frustrated and didn't know how to create a new graph, if you just go to the home page and go here, we get a brand new graph. But we're going to type in your equation. So you should have put in negative 4.9. Again, use x, don't use t. So negative 4.9 x squared plus 15x and plus 2. And just like before, we see part of our graph, but we don't see the whole thing, but that's enough to be able to answer our questions. But first, let's go back and figure out what the y-intercept is. Again, the y-intercept is where x, in this case t, is 0. And if you put 0 in there for t, you end up getting 2 as your answer. So for this, the y-intercept represents the initial height is 2 meters. Everything here is going to be in meters this time because our equation starts out with negative 4.9. So that means that they took half of 9.8, meaning that everything would be in meters here. So to find the positive x-intercept, you should have done this. You should have, at menu, analyze, we're looking for the 0. Figure out what that is. You get 3.20. So that means your x-intercept is at the point 3.20. I'm not going to take the time to write this right now, but you should have written down that what it represents is that the ball hit the ground after 3.2 seconds. And to find the vertex, menu, analyze a graph. Again, we're finding the maximum. Start out with your lower bound and upper bound. And you should have gotten a vertex at the point 1.5 and 13. And in this case, what this represents is that after 1.5 seconds, the ball or the object reaches maximum height of 13 meters. Well, that's it. That's all we had to do to figure out how to find those different pieces as far as the vertex and where the ball hit the ground, or the x-intercept, and where the initial height was, where the ball was or object was first thrown, was the y-intercept. So using those different pieces and using your graph, you can be able to answer those questions. So again, make sure that you know how to use your calculator, because that's going to be a very important tool for you in the future and as you move on throughout this course. Well, with that, good luck on your future power standards.